So your scatter plot should look something like this. Again, our scale might be a little bit off, so it might be hard to tell how the correlation is doing, which is why we then would like to bring in our Pearson's correlation coefficient. So it says describe the association here, calculating and interpreting R if appropriate. This thing right here is really important because if appropriate means if it is a linear association. So if you were to describe the association and say that it is a strong, which it is, positive, which it is, linear correlation, which it is, that then you would use the Pearson's coefficient. You would calculate the Pearson's coefficient, and that would be when it is appropriate. So we are now talking about two different points of data, two different variables. We're talking about heat and length. So it's no longer about frequency. It's about two things being compared together. So we're still going to use our stats table area. I'm going to delete all the things I've got going on in here. Actually, okay, so this is the data that you have already. I had put it in last night, and so then it's still in. So go ahead and enter it all in. Notice that in the first column, I have all of my heat represented. In the second column, I have all of my lengths represented. And since this is two different things we're trying to compare, now when we go to statistics and we start our stat calculations, instead of doing one variable statistics, we're going to do two variable statistics. All right. Go ahead and pause the video if you haven't filled in all of the data. If you have filled in all the data, fantastic. We're going to hit menu, go to statistics, stat calculations. Instead of one variable, now we need to do two variable statistics. Now, we had two lists, right? We have an X list and a Y list. Our X list was in A. It was in that first column, which we call A. And then our Y list was in the B column. I think hopefully by now, TI-84s, you should be able to figure out what's going on here to be able to work it out. Remember that you also can go online and Google it, and there's tons of people out there who want to help you out. Okay, so X list is in A, B list, Y list is in B. We're going to put our results in column C because there's nothing there. And there we go. We have all of our results. So we have the mean of our X values, which is nice. We also have like the sum of all of our X values, the sum of our X values squared. We have the standard deviation, which is right here of all of our X values. And we keep going. And then we have the mean of our Y values, the sum of our Y values, the sum of our Y values squared, the standard deviation of our Y values, the sum of our X and Y values multiplied together. And then we have R. So R is just right here, and that is the number that we are looking for. And R is 0.955. And think about it. Remember that if it's positive, it means it's going to be sloping upwards, which it is. It's sloping upwards. So this is a positive correlation, which we wrote down. And 0.955 is really close to 1, which is also something that we talked about, the fact that it is a strong linear correlation. And your Pearson's product coefficient also agrees with that. Okay. Example number 2. A student interested in whether the mass of a vehicle affects the fuel use. A student is interested in this. Oh, okay. They did it on 15 small cars, and then here's the results. We're going to go ahead and graph this table again. So putting in our X and Y axis. I'm going to go ahead and start here with 100 or 1,100, and then I'm going to go another 2 and do 1,200, 1,300, 1,400. And since I jumped from 0 to 1,100 and then it was a consistent amount of scale, this is where I would put this little zigzag guy, just to tell the person who's reading it, like, hey, I realize that that scale is not consistent, right? Adding 1,100 and then adding 100 every two is a big change in the scale. So this is me just saying, hey, I realize I just jumped further along in the x-axis in order to be able to accomplish this. I am going to go ahead and start here with 10. And then I'm going to go up by twos. So it's going to be 10, 12, 14. But I'm going to actually just label every 4. So I'm going to do 10, 14, 18, but realize that that's 16, 18, 20, 22. And again, this took me a long time to figure out. I have my little cheat sheet that I already made the graphs of, so I'm just telling you what I eventually figured out. Again, the scale changed here, so we have to do a little zigzag at the beginning to say like, hey, I realized I just jumped a little bit further up on the y-axis for us to focus in on the part of the graph that we actually care about. I'm going to go ahead and pause the video here for you to finish the scatter diagram on your own. Okay, this one was a bit of a pain in the butt to do, but your scatter diagram should look something like this. Describe the association. First of all, I want you to point out here, hopefully you notice that there is a pretty clear outlier in this diagram. This diagram is a very clear indication that we have an outlier. So we can say, and while we're not in the data analysis aspect of it, we are going to dismiss the outlier. Remember that in the application of this, as a statistician, we would not ignore the outlier just when we're analyzing the actual data of it. We ignore the outlier when we're calculating R. Because R is greatly affected because that's obviously way far out and makes a way less of a correlation, whereas everything else, it's a fairly strong one. So we could say fairly strong correlation. We could say here that it's a strong positive linear correlation if we dismiss or ignore the outlier. So that being said, we're going to go ahead and put this data into our calculator. And we are not going to include the outlier. And the outlier is this guy right here, the 1400 and 11.3. So I'm going to circle it to be like, hey, that's the outlier, so I don't input that into my table. All right, so hopefully we've entered in all of the data. We're going to do menu, stat calculations, 2 variable statistics. Make sure to include both your A column and your B column, and then we enter it into C. And then what I'm looking for here is R, which it already jumps down. Remember that like it starts off way up here. So we were already jumped down that far. And so we have our correlation here of 0.98, which is a very strong, or we'll do 366, 0.980. Oh, there you go. Which is a strong positive correlation. Now, if we were to put in the outlier, so go back in here and we're going to go put in the outlier, which is 1400. And then 11.3. It says error here because I don't have something matched up with it. But now that I press enter, it's added in and it makes it significantly less strong. It's now closer to more of a moderate range. So it does greatly affect what your outlier is. All right, last problem. A student in a physics class collects data on the height of an object at different times after it is dropped from a height of 35 meters. The data is given in the table to the left. Create a scatter diagram. So I'm going to have time down here and height up here. Oh no. Well, I guess it's red. All right, if I want to go all the way from 0 to 2.5, I'm going to go ahead because I know that this is 20. And I notice that it goes up by 0.25, which means that that's going to make 10 quarters. So I'm going to go every 2. And I think that's 0.25, 0.50, 0.751. Also remember, I've done this a long time. So remembering and figuring out these scales was something that I had to struggle through and figure it out and get comfortable with when I was your age. And now it's literally my job to do this all the time. And that's why I'm quick. I realized that there were 10.25s. I knew that this was going to be a distance of 20. So I said, oh, well, that means I can go every 2, and I would still get from the beginning to the end. Because 20 divided by 2 is 10. All right. Our smallest number here is 10. And our largest one, oh no, sorry, our smallest number here is 4.38. So I have to really start at 0 here. And then I need to go all the way up to 35. I'm going to go every 2, and every 2 is going to be 5. I think. Okay, so that should be your scale for your graph, and go ahead and I'll pause the video. Complete your scatter diagram. All right, so after you finish your scatter diagram, to describe the association, it is a strong, negative, but non-linear correlation or association, yeah? So it is non-linear. And so here where it says, oh, it should have said if appropriate, calculating and interpreting R if appropriate. R is not appropriate in this case, so Pearson and his coefficient is not appropriate because the correlation is not linear. So since the correlation is not linear, which makes sense, we've seen all sorts of trajectories of projectile motion, and all projectile motion creates this parabolic curve that goes down like this. And so since it's not linear, which we could have interpreted or guessed from the situation that was given to us, we cannot calculate Pearson's coefficient, and as a result, we do not have an R. All right, so the main idea of these notes is that we have a correlation, we have our scatter diagram, and as long as it's linear, we can calculate this thing called Pearson's coefficient, which uses the letter R to represent it, to tell us what direction this linear correlation is going in and how strong the linear correlation is. And it's all between -1 and 1, and it gives us all of that information. All right, guys, good job today.